In this series of videos, we are going to talk about polynomial functions, characteristics of those functions, as well as the graphs of those functions. In this particular video, however, we're going to start by defining a polynomial. A polynomial is officially defined as a function that is in the form of this long thing right here. You have the sum of the monomials being added together. Each of the monomials are raised to a particular power. The power that the exponent of my variable, which is here indicated as n, the exponent of the variable has to be a non-negative integer. In other words, all of the exponents for the variables in the function are going to be positive whole numbers. We also have here, this is a special term. This would be the leading term, and it's the one with the highest exponent. Remember, that's when we write it in its descending order, so this guy is going to be the one with the highest exponent. And then that coefficient a would be the leading coefficient for the leading term. The last term down here, notice there's no variable associated with that term that you see. There is one there. Think about that one for a minute. But anyway, this term down here, this is just a constant term. Okay? The degree of the polynomial is the largest power of x that appears in it. So we can identify polynomials such as 5th degree polynomials, 10th degree polynomials, or whatever. It's based on the degree of this leading term. So let's look at a couple of examples here to just identify whether or not something is a polynomial. If I'm looking at this right here, this first function says f of x is equal to x squared. And I want you to think, is that a polynomial? Yes, it's a polynomial because the variable is raised to a positive integer. So sure, it is a polynomial. It is in fact a quadratic, and it is a special polynomial because we deal with them so often. Moving on to this example right here. This is 3x plus x to the 5th. This is a polynomial. It is a 5th degree polynomial, and it's just not written in descending order. But sure enough, it is a polynomial. We have the sum of the monomials. How about this one right here? This says f of x is equal to 4. Is this a polynomial? Yes, it is a polynomial, and the reason for that is because we could write 4 as 4 times x to the 0th power. And x raised to the 0th power is still a non-negative value, and anything raised to the 0th power, remember, is just 1. So yeah, it's a polynomial. We just don't always think of a horizontal line, which is what this is. We don't think of it as a polynomial, but it is. Let's look at this one right here. This says f of x is equal to 2x squared plus x to the 1/2. Is this a polynomial? No, this is not a polynomial. It's not a polynomial because of this exponent here on my variable x. This exponent is a fraction, and we have to have non-negative integer values. Remember, whole numbers. So that's why this is not a polynomial. So that is the formal definition of a polynomial. And next we're going to look at some characteristics of polynomials.